Thank you. Be on the lookout.
Next up, we're going to be hearing from Kayla Brower, who will be talking about the impacts of honeybee hive placement on blueberry pollination.
All right. Well, my name is Kayla Brower, and I'm a first-year master's student in Dr. Lisa DeVetter's Small Fruit Horticulture program. And I'll be presenting on my research, hive placement, improving pollination, and promoting honeybee health. Ooh. There we go. Okay. I have two research questions for my project. The first, does hive placement impact blueberry pollination and yield? And the second, does hive placement in blueberry fields have an effect on honeybee exposure to pesticides? So first, a little bit of background on blueberries, which is probably pretty well known for everyone in this room, but Washington State leads in national blueberry production. In 2021, Washington produced 180 million pounds of blueberries, which accounted for 27% of the total national production. But berry development depends on insect-mediated pollination. Due to the low abundance of native pollinators, like this queen bumblebee on the left, farmers rely on rented honeybee hives. But there are gaps in knowledge concerning the placement and density at which to stock bees in order to obtain acceptable pollination. So in the broadest terms possible, pollination is the movement of pollen from anthers to stigma in order to get berry development and growth. And in blueberries, this movement must be done by an insect. So this is a really great graphic put out by the USDA showing the movement of managed pollinators throughout the United States. So most of the hives that blueberry farmers are getting in Western Washington have just either come out of citrus in Northern California or from apples and cherries from Eastern Washington. And I think this figure does a really good job of demonstrating just how stressful the life of a managed pollinator is. Not only are they being moved every 6 to 10 weeks, they can be exposed to a wide variety of chemicals, not only in the agricultural systems, but even just on the highways and roads. And their diets can be really limited depending on what crop they've been put in or what ecosystem they're near. And I think it goes to show that we can, even if there's really small things we can do to support pollinators, these managed pollinators, it could go a long way in making sure that the system is sustainable. So now a little bit on flower morphology. Blueberry flowers can be very hard to pollinate. Okay, sorry, there's a spider on the screen. Okay. So blueberry flowers can be very hard to pollinate. Not only is this throat diameter of the flowers very small and makes it hard for pollinators to get in there, the flower overall length can be very long, which makes it difficult for pollinators to get in and pollinate too. But the anthers require sonification or buzz pollination to release pollen. So these anthers must be vibrated in order to release pollen, and then the pollen must be moved from the anthers to the stigma. And bumblebees are able to sonicate, but honeybees do not. Blueberry pollen is also not ideal for honeybee foraging. It lacks certain nutrients they're really going after. So when honeybees are on blueberry flowers, they're mostly going after the nectar at the bottom of the flower. By increasing honeybee visitation rates through different placement strategies, it could be possible to improve pollination of hard to pollinate cultivars like Liberty and Last Call. So my first question, does hive placement impact blueberry pollination and yield? So the treatments for the study, it was a paired design, and our treatments were clumped and dispersed. So up here, this was our clump treatment. So it's a high number of hives in a few drop locations around a field. And you'll notice that there's a greater distance from field edge compared to our next treatment. So our dispersed treatment, it was just a few hives that were widely dispersed around the perimeter of the field, and they were put right against the field edge. So this was a really big study between a lot of collaborating institutions. So we had 3 different study sites. In Washington, we had 6 pairs or 12 fields total of Duke. In Oregon, there was 3 pairs and they're also Duke. And in Michigan, there was 4 pairs of blue crop. Data was collected in 2021 and 2022, but the data I'll be presenting is just the Washington data. So how do we actually determine if there's differences due to our placement strategies? So our first step was looking at pollinator activity. So we measured this by doing scan sampling. So we would establish a row when we go into this row a little ways, and then we'd measure out a 330 foot transect. And then we'd slowly walk down this transect and take note of every single honeybee, bumblebee, wasp, fly, any pollinator we saw actively foraging on a blueberry flower, we counted. And then from that, we can get an idea of how many pollinators are active at a given time. And then to assess for pollination deficits due to our different treatments, we established 20 different bushes throughout the field. So that's 5 per transect, and each received an additional 3 subtreatments. So these subtreatments were field level conditions, pollinators excluded, and hand pollinated. So what that means is on this bush, we tagged a representative branch, we labeled it with a 1, and for field level conditions, we did nothing else to it. And then for our second branch, we tagged this representative branch, and then we put this mesh bag over top to exclude all pollinators, but allow the fruit to develop normally. And then for our hand pollinated treatment, we tagged the branch, and then twice throughout the bloom period, we went through and hand pollinated every single flower on that branch. And then after the fruit developed, we went back and harvested, and then we used fruit set, seed set, and fruit weight as metrics to determine if deficits exist. So here's a more graphical way of looking at our approach. So here we have our field. It was either clumped or dispersed. And then we had our 4 transects that were 330 feet. And then from our transects, we'd do our pollinator walks. We would count bees and flowers. And then from that, we can get a honeybee rate, or the number of honeybees per transect per hour. And this is just an idea of how active the bees are. And then on each of our transects, we had 5 bushes on every transect. And from these 20 bushes total, we do our subtreatments of hand, bagged, and open. And from that, we can get seed set, berry weight, and fruit set metrics. So first, I'll present the data we got for our honeybee rate. Before I do that, just briefly mention what a p-value is. So p-value is a measure of the probability that you have a treatment effect. The lower the p-value, the greater the statistical significance of the observed difference. So what that means is in my next slides, if you see a p-value that's smaller than 0.05, we had a significant effect. So first, our honeybee visitation data. So this is data from optimal foraging days, and an optimal foraging day is when it's sunny to partly sunny, over 55 degrees and low wind. That's conditions honeybees like to fly in. And we found that clumping hives resulted in greater bee visitation when conditions were optimal. So we had a small p-value for our treatment effect. I also have this year effect, and that would just indicate if the data collected from year to year was very different, which it wasn't in this case. On this graph, we have our honeybees per transect per hour, and our placement treatments are clumped and dispersed, split up by year. And you can see the clumped resulted in higher honeybee visitation rates. I then repeated this analysis on suboptimal foraging days. So that's when it's overcast or rainy, less than 55 degrees and windy, which basically defines pollination for 2022. And we found that hive placement did not significantly impact honeybee visitation when conditions were suboptimal. Our treatment, we had a high p-value for our treatment and no year effect. So next, I'm going to present some of the data that we got from our different berry metrics. And all this analysis was just done on open branches to simulate what's happening in the field as a whole. So first, fruit set, and how we determined fruit set was on our branch, we counted all the flowers during bloom, and then after harvest, we counted all the fruit we collected in order to see if all the flowers successfully turned into fruit. And we found that placement had no significant effect on fruit set. So we had these large p-values for 2021 and 2022. We did have a year effect, which we were expecting just because 2021 was a great pollination year and 2022 was a pretty poor pollination year weather-wise. So next, our blueberry weight. So how we determine blueberry weight is from our branch. We would randomly choose a berry and we would weigh it, and then we take averages for each transect to get an idea of what the overall berry weights were. So on this graph, we have our blueberry weight in grams right here and our different treatments here. And again, we found that placement did not have a significant effect on blueberry weight, high p-values, and a slightly significant year effect. And lastly, for seed set per berry, so how we found seed set is we took a randomly selected berry from our branch and we smashed it and we counted every single viable seed in the berry in order to get an idea of how the berry matured over the season. And again, we found that placement did not have a significant effect on seed set per berry. So high p-values, and we had a crazy low p-value for the year effect. And we would have thought that 2022 was a poor year, but we actually had higher seed set. And our going theory for that right now is that plants were so stressed in 2022, they were putting more towards reproduction than sizing up of the berries. So then my second question, does hive placement have an effect on honeybee exposure to pesticides? So a little bit more background. Hives generally leave blueberries less healthy than when they arrived. They don't size up and there's more instances of brood diseases, but there's gaps in knowledge concerning why the hives are leaving less healthy and why these instances of brood diseases increase while they're in blueberry. It could be to nutrient deficits in pollen, it could be due to pesticide exposure, it could be to a wide variety of other factors we just don't even know yet. So the methods for the study, the treatments were the same as in question 1. So we had our clumped and dispersed sites. And then what we did is in each of our field sites, we deployed these silicone bands on 10 different hives in the field. And 5 of those hives faced towards our study site, so towards the blueberry field in most cases. And then 5 were facing away from the blueberry site. And we deployed these at the beginning of bloom, and then they passively sampled pesticides throughout the bloom season. And then we send them off to a lab at Cornell, the McArt lab at Cornell, and they do the analysis for us. And then in 2023, we're planning to do an in-hive pesticide residue sampling. So this is some initial data, and before anyone gets a little too heated about it, it's all initial, it's not been analyzed, and so we'll just go through it and calmly and collectedly. And so this is from Michigan too. So this is only 3 sites from Michigan. Cornell had some issues with the methodology of the analysis, so they haven't gotten through nearly all of the samples we sent them. So this is just 3 sites, 2 were clumped and 1 was dispersed. And in Michigan, they detected miticides, herbicides, fungicides, and insecticides. And it's notable that in the dispersed site, the towards facing hive had much higher amounts of pesticides detected than the away facing. But again, this is all preliminary data. It's not been analyzed. It's just the raw data. And it's also important to note, it's only looking at what has drifted onto the hives. And this doesn't necessarily tell us what's happening inside the hives and how it's affecting hive health overall. So there's lots of future work to do. We're going to continue data analysis of yield and berry metrics for Washington, Oregon, and Michigan. We're looking to incorporate a pollination service and pollination limitation approach that's used in ecological studies. We're going to continue silicone band analysis for 2021 and 2022. We're going to do an in-hive pesticide residue study. And then we're also going to look at the economic impacts of each placement strategy. And then the big overall project that I'm helping work towards is creating this decision aid tool that will be available to farmers that will incorporate all sorts of different metrics that will allow them to make informed decisions about optimizing pollination in their fields. So here's some main takeaways. Hive placement increases honeybee visitation on optimal days. Hive placement does not impact yield and berry metrics in the cultivar Duke, and hive placement and orientation may impact the amount of pesticide residue hives are exposed to. So with that, I'd like to thank the Small Fruit Horticulture team, the collaborating institutions, and the Specialty Crop Research Initiative for funding. And are there any questions? got it. Right.
Oh, here you go.
Do you have any data on that bee pheromone, if that makes a difference on the pollination?
Oh, bee pheromone? No, this project did not have any of the bee pheromone aspects to it, but there are other studies that have been done that have that component.
From your experience, is it a good idea to use that bee pheromone or not?
I haven't done too much work with the bee pheromone. There's initial data, and I think Dr. Lisa DeVetter would be someone to talk to at a later date about that after she's had some time to look at the data.
Any more questions for Kayla?
What type of honeybees were used?
Just the Apis mellifera,
Did you control for or maintain like constant distance between the sample bushes and the clumped or like a weighted average for the scattered hives?
So the distance between all our bushes in the field, are those the ones you're referring to?
Yeah, so like the sample bushes that you were.
No, those are pretty randomly dispersed. So we'd walk, it's usually we try and make it about 3 to 5 meters between each bush, but it wasn't necessarily exactly 5 meters between each
Okay.
bush.
I didn't mean the distance between the bushes themselves,
Oh.
but the distance between like the bushes that you sampled and where the hives were.
No, that varied pretty widely. So in the dispersed sites, that was the ones that were right up against the field. That one was pretty easy because they're almost touching the poles. So it's like less than a foot. Our clumped sites, those ranged pretty widely. We had some that were 40 feet away, and then we had one that was almost a quarter mile away.
So on average, the clumped hives were further from the.
They were
sample
much
bushes.
further away than the dispersed hives.
Any more questions? Okay, thank you very much, Kayla. And that concludes this speaker session. If you're looking for pesticide credits for Washington and BC, they'll be in the back corner there. And our next speaker session will be in the expo room starting at 11:10.